Hi, we're Allen's Angels, and this is our progress so far in question generation.
We use the spaCy NLP package for Python to do our question generation system. It has support for 3 features that we use, which is the part-of-speech tagger, as well as the dependency parser and the named entity recognition feature.
One way of generating binary questions is by identifying auxiliary verbs in a sentence. So we would run our POS tagger on a sentence, and we would get these syntactic dependency tags. So for example, this token would be marked with AUX for auxiliary verb. So what we then do is identify the location of that and move it to the front of the sentence to create a binary question. So this sentence would then become, can she write?
Okay, another type of binary question involves the English do construction. This would be generated from a sentence that has a non-copula finite verb as the root. So the spaCy tagger would, in this example, identify writes as the root, and notice that it's finite. So to generate the question, what it would do is put an appropriate form of the verb do in front, which would be does in this case, and then change the root into the infinitive form of the root. And we get that, does she write poorly?
Okay, so I'm going to talk about how we generate WH questions for our project. So we use named entity recognition to generate meaningful questions. So for example, we basically had a dictionary of all the different entity types, and we had a direct one-to-one mapping to a word that would be an appropriate replacement in a question. So for example, for the first one, if we had a sentence such as Jim sold a car to Jerry, and Jim was detected as an entity, the generated question would be who sold a car to Jerry? That the entity appeared in, and replace that whole noun phrase with the keyword. So for example, the New Democrats are worried about elections. We wouldn't want a case where Democrats is tagged as the entity, and we generated questions such as the New Who are worried about elections. Therefore, we basically detected the whole noun phrase and replaced that whole thing with the word of our choice. There's a couple of different ways we want to evaluate the questions that we generate. So the 2 criteria that we're using to evaluate are, is the question grammatical and is the question answerable? And we're going to look at that for the 3 different types of questions that we generate. So most of the questions we generate are answerable because we're lifting them directly from sentences in the text. However, sometimes ambiguous questions are not answerable. So for example, if we have a sentence called the test is ready, it is hard, then binary question generation with auxiliary verbs will output a question, is it hard, where the it is ambiguous. So that might not be an answerable question. Sometimes questions can also be not grammatical. So for example, again with binary generation over here, we would identify the first word that had an auxiliary verb tag and then place it at the front, but the resulting question is not grammatical. When we are generating questions, when we look at finite verbs, sometimes if the sentence structure doesn't match our expectation, we aren't able to parse it in the way that we want to generate questions. So for example, if we have a sentence with relative clauses, with multiple verbs in a sentence, or with a sentence in reversed order, we're not able to generate questions in that way.
So some future plans for question generation and how we can improve what we've done so far is checking the reasonability of a parse of a question. We can also penalize questions for being overly verbose or lengthy. And lastly, we can run our question answering algorithm on it, and from there determine if that question will give us a good answer. These are our plans for question answering.
So here are future plans for question answering. So the first thing that we want to do is once we get a question, we want to identify the relevant passages in the text that could be potential answer sources. So what we'll do is use calculate TF, IDF, and cosine similarity for each sentence in the document with the question itself, and figure out what the most relevant passages are in the text. So we've already identified several tools to do this, such as spaCy.doc.similarity. The next thing we want to do is identify the question type. So once we know the question type, we can either narrow it down to binary WH questions to begin with. So for binary questions, we're going to be looking for the question words in the passage itself. Next thing that we wanted to consider was WH questions. So again, we're going to be looking for all the key question words, but another thing that we want to be looking for is that we want to be looking for the name entities of the correct type.